This was esters. We talked about that yesterday. You'll recognize an ester when you see that in the middle somewhere of the compound. See double bond to O right there, and then also single bond to an O, which is in the parent chain. Another type of condensation reaction is what we call the Amidon Formation. Some people say amid and some say amide. An amide is formed when you have an amine compound. Amines are organic compounds that have nitrogen in them. That's how we know those. Amines with acids are going to make amides. And it is also a reaction that condenses and gives off water. This is very similar to a formation of an ester. Did you not? I saw folks were writing that down. Can I just go back one slide? You did not write an example of an ester down yesterday? Others said that they did. Well, maybe not that one, but it's the same idea. You just need an acid to meet up with an alcohol, and then we're going to lose a water molecule, and then these two will combine, like condense together. Remember?
How do you name an ester?
You're not going to have to. This is off the record because I don't want you to say, oh my gosh, I'm never going to remember that. Well, you don't have to. I'm not going to ever ask you what the name of an ester is. But if you want to know, what you would do is you would name the part that was the acid first, like this is F, right? And then this was, both of these are ethyl groups. The second part, I said that wrong. I have a memory trick for this one too. It's probably not one that should be recorded. I'll tell you what it is anyway. You name the alcohol first and then the acid. And when you name the acid, you end it with O8. So this one would be called ethyl ethanoate when it's formed. Ethyl ethanoate. And the way I remember that is this. I think of a girl named Esther that drinks too much. And what I say to myself is, when Esther drinks alcohol, she turns into a real acid. So that's how I remember it. Alcohol first, then acid. She got to drink the alcohol, then she acts like an acid. Memory tricks, the zanier they are, the better. The more you remember. Parameta ortho? What, you have an Esther?
Yeah.
Oh!
She's like one of my best friends.
Okay, that's going to be our secret. Okay. Cut!
How can you tell an acid from an alcohol? Because they both have OH.
Yes, but when an ester forms, both of these compounds are going to keep one oxygen. And that's a way you can remember it too. So the acid keeps that oxygen, therefore the alcohol has to keep its oxygen. Okay? Each of them is going to contribute one oxygen to that ester link. So that part had to be the alcohol, that part is the ester. And that was for everybody. It's not just answering one person's question. You're going to see at the very end of today, we're going to be talking about polymers, and some of the questions in the book, they ask you to kind of deconstruct a polymer. They're going to say, here's a section of a polymer. What monomers were used? In other words, what small molecules were used to make this thing? And some of these are polyesters. And so you're going to have to recognize, oh, when you have to take apart an ester to see what it was made of, you have to know that one of the single bonded oxygen goes with the alcohol part, and the double bonded oxygen goes with the acid part. Amides are the same kind of a bond, where you have the OH coming off of the acid, one of the H's coming off the nitrogen. Nitrogen has two H's on it, one of them comes off. You get the water molecule, there it is right there, I had it in red. And then we get this linkage between, there's the C double bonded O from the acid, connects with the N. Now I should have probably put the H like off like that. So it shows that the carbon is directly attached to the N. Carbon's not attached to H. You know the H doesn't go in the middle though. You know that, I guess. So yeah, that thing right there, that makes this compound an amide. Now this may seem like, oh gosh, he's giving us so much detail. I've never heard of amides before. Why would I care? Can I just live my life without amides? Yes, you could live your life. Actually, you couldn't, because we have amide connections all through our body. Have you ever heard of a peptide bond?
Yes.
What's a peptide? Yeah, in what? In anatomy? What's a peptide? GBBE? It's the bond that holds a protein together. Yeah. Peptide bonds are the same thing as amide bonds, the exact same thing. What is the building blocks of a protein?
Amino acids.
Right, amino acids. Amino acids are compounds that have an acid on them, and then there's a carbon with some other things on them, and then there's an amine. So this compound, the side chain on the carbon dictates what amino acid it is. How many amino acids are there?
20.
20, that's right. So they vary in the number of carbons in here and what the functional groups are between the acid group and the amine group. That's what varies in amino acid. It would have been great to have this class first and then learn about amino acids. You'd understand it so much better.
For the slide on there, did you cross off the H afterwards, or?
Yeah, I crossed off after. I'm just saying that I probably shouldn't have put the H there. I should have had it off so that you would see that the carbon really is attached to the nitrogen. It's not attached to H. Okay. So anyway, yeah, when you have a, here's one amino acid. When the next amino acid comes along, and you know, whatever is on there, it doesn't have to be the same necessarily amino acid. Then you get this. These two make a water molecule, and these join together, and that bond that those two make is going to be the C double bond O to the N. That is an amide connection, also known as a peptide connection. That's about all the biology I know. So, you know, if you ask, oh, what would happen if you drank, you know, acetone or whatever? I don't know, because I don't understand any biology. Okay, yeah, so anyway, amino acids are connected with these kind of things to me. Are we good? After this one, I'm going to have one more condensation reaction for you. These are also known, by the way, as dehydration reactions. Does that make sense? Why would I call them dehydration reactions? Because we're losing water. Yeah, that's what dehydrate means, is to lose water. So in both cases, forming an ester and forming an amide, water is released, dehydration. One more kind of dehydration is dehydration just of alcohols. If you have an alcohol reacting with another alcohol, you're going to get a compound known as an ether, another type of organic compound. So it's another dehydration reaction. The OH comes off of one of the alcohols, and just an H comes off of the other one.
Is this called an ether formation?
Uh-huh. So you're going to have these two compounds losing the water and condensing to this thing, which is an ether. So yeah, you've got the 3 carbons with the O right there, and then 4 carbons over here. Does anybody know anything about ethers? Have you ever heard of a substance called ether? It's got a couple of uses. Dentists used to use ether for a crude anesthetic. Back before there were good anesthetics like Novocaine, they would rub ether on the patient's gums and before they pulled their teeth or whatever they would do back then. There's a big problem though using ether. They used real bright lights, of course, like your dentist's office does, and a lot of those bright lights had an open flame in them. Ethers are very flammable. That's a problem. So there were several dentist offices that burned down because, you know, in a small room, you've got this volatile, very flammable ether with their bright light using an open flame. So, yeah, they don't use ether anymore, the dentist offices. They don't use open flames either, I guess. Also, ether, if you ever, or if your dad uses small engines, sometimes if you can't get your lawnmower to start or your snowmobile to start, motorcycle, even old cars, you can just take a bottle of ether. You can go to a hardware store and buy a bottle of starting fluid. It's got this compound ether in it. And so you just spray it right into like take a spark plug out of your motor and spray the ether in there or into the carburetor. And man, that helps it to start very well. It's very flammable. So that's mainly what we know ethers are for. Just know, you don't need to know the properties of them, but if you just recognize an ether compound has oxygen in the middle of the molecule somewhere. It's not an ester because an ester has the carbon double bonded to an oxygen as well as the oxygen. It just has the oxygen. Yes?
Can esters and ethers be constituents?
No. I don't think so. I think an ester would have to be part of the parent, and ether would too.
So
I
the
don't
whole
think
thing
they
is ether?
What about?
The whole thing is ether?
The whole thing is, yes. Some carbon chain with an oxygen right in the middle somewhere. An oxygen that's just right in the middle of the carbon chain. Now, directly in the middle? No, not necessarily, but someplace between the ends of it. Yep, in here. Okay, now that's going to take us to the last topic that's in the chapter, and that's the formation of polymers. We're going to do a lab on Monday. It's a great lab. You're going to enjoy it a lot. We're going to make 2 different polymers. They're both very interesting polymers. Both are polymers that you've dealt with in your own life that we'll make, and it's neat. So let's learn some things about it first. Poly, of course, means many. A polymer is a case of taking an organic molecule and causing molecules to bond to one another so that you get a real long chain. And when I say a real long chain, literally, not literally a chain, but very, very long molecules. Polymer chains can go 100,000 to 1 million to more than that number of carbons long. I mean, these can get to be gigantic molecules. The simplest polymer of all is polyethylene. Polyethylene has all carbons with just H's coming off of it. It's just like a methane almost. This is the methane of polymers. Because it doesn't get any simpler. And when you look at that, it's not intuitive. What do those symbols mean at the end? What does the line mean across the parentheses? What that means is, when I write this polyethylene, this is just a snapshot of a very long chain. So when I'm just giving a snapshot, I'll just write several units of the polymer and then close it off with parentheses. And that line across the parentheses just means that, yeah, the chain continues. On both sides. I'm not very interested in writing 1 million carbons on the board. So I just write it apart. And I don't really need